Hello, everybody. Welcome to week 6. This is our lab video lecture on framing. So we're talking about wood technology in our lecture and your reading. And so now I just want to kind of go over the house that you're working on for estimating and give you some visuals of what the framing looks like. I know my two videos from the book from the PowerPoint were pretty boring with just the black and white words and some photos. It's always nice to be able to see these things in real life. Typically when we have classes in person, I try to get you guys to a job site. So this is my next best thing, is showing you the actual framing of the project that you're estimating. We're also going to do some labor cost as well as material cost, and I will go over that as well too. But first I'm going to show you this PowerPoint. All right, so here is the family room, and on the left side we're looking at the wall that the fireplace is going to be installed. Sometimes the fireplaces are built outside of the building envelope. This house, this client in particular, wanted that fireplace built on the inside of the family room and having the windows flanking the fireplace so they could create these little nooks on either side, because the fireplace actually comes out 2 feet. I don't know if I have any other pictures on this slideshow of it actually being framed, but you'll see it as we go, and you'll see some finished views of this wall in particular. But the built-ins were not completed at the time that I finished this house. The homeowner was going to do that later on, but what he was going to do is put little seats on either side of the fireplace under the window. Nice little place to read. I think we ended up putting a light. Yes, we ended up putting a little light over on this side, so that way if somebody was sitting and reading, they could actually turn on a small light as to not bother the rest of the room. Remember, we were talking about truss roofs. This is a beautiful picture to show you what the inside of a truss roof looks like. And remember, we were talking about the scissor truss, right? And how I have a different pitch or a different slope on the outside as I do to the inside. So this is what I was talking about. This is a different pitch. It's about a 3-inch difference in pitch from the main roof, and that was to allow insulation in this outer part. This is an exterior wall over here on the left, so this outer part right where these rafters hit that wall, I needed to be very careful to make sure that I was able to achieve the R value that's needed for new construction, which is an R49. And you're going to learn about insulation. Don't worry if you don't know what that means right now, but that is the value that is put in our attics, and we'll go over that again through insulation. You can see that I have some temporary, not I, the framers, because I don't frame, let's be clear. But anyways, the framing crew put up these temporary supports until everything is completed, and the hurricane ties. Hurricane ties are straps that we actually attach to the roof structure and to the exterior wall where they meet, to be able to hold that roof system down to the exterior wall. And until those are installed and your ceiling joists are installed, all of these temporary bracing are going to be left in place until the framing crew is pretty much completely done with the frame. As you can see, the rest of the job site is pretty clean. I take a lot of care in cleanliness of job sites. It's OSHA certification to be able to have clean job sites, as to not allow anybody to trip over anything. You can even see that I have this rolled up electrical cord over here too. It's not just all draped around the floor, is it? It's nicely tucked away. All of the pieces, scrap pieces and such, blocking that we might be able to use down the road, all of these details are put in there. Moving on. So I do take a lot of pride in making sure that my job sites stay clean, but you're subcontractors should also be making sure that they do that. These framers that framed this house were very, very particular about cleanliness, which is always, always great, because then I don't have to do it or you don't have to pay someone to do it. So over on the right hand side is a picture of the staircase. Is a picture of the staircase looking up at, again, the truss roof system, looking up at that little landing that I had talked about previously. Hopefully I've talked about that already, but if not, this is going to be a little landing up at the top of the second floor before you hit the hallway for the bedrooms. And then this window here in particular, this wall is facing not due south, but in the southern area of orientation. And the light that's projected through these windows coming down through this staircase is absolutely beautiful. So, you know, when we talk about placement, I don't talk about it a lot in this class, but in our sustainability in the built environment, we actually look at orientation very, very clearly. And we work on site plans, being able to understand site plans, because even though we're builders and project managers and designers, you still need to be able to know where the sun is. You still need to be able to know where wind is coming from on your property. And is there views, and is there other details that you can utilize to make the experience better on the inside? So this window is super cool, lets in a lot of beautiful natural sunlight into this staircase. So not a lot of artificial light is needed. This was a cool detail. I'm going to get into like headers and things of that nature, but right up here, this different color than our kiln dried studs, floor joists, ceiling joists, and trusses. This is an LVL. This is that laminated beam that I talked about briefly and that your book talks about. So these are those beams that we can span long distances before having to have point loads. You can also see there's one stepped back here a little ways. And so these are carrying weight of the second floor walls, floor joists, and roof system. Okay, ceilings, roof system. You can see that we have blocking going across there. So these are our interior studs that I'm putting a circle around right now, 2x4 at 16 inches on center. You can see that these corners have a couple different studs on there, don't they? There's 3 studs. So we double up, triple up, things of that nature. Up top here, you can see that we have quite a few. This is a, let's see, I was trying to see if I had a different picture of this, but anyways, this is carrying down some load from the roof. And so that's why there's multiple different studs up top here. What else do I want to show you on the zip sheathing? Here's the zip sheathing. I'll show you this on the exterior too. But we ended up, you know, sometimes you use what you have. We don't want anything to go to waste. And so this was a gable end on one side. And so they just brought that sheathing down, even though it's on the inside. There's a portion of this wall that's actually hitting the outside. So we just carried that zip all the way through, which is fine. This is just a little closer detail of your LVL beams. And then again, see this LVL beam that stepped back. You can see some silver around these floor joists here. And what that is a joist hanger. So instead of dropping, these beams could typically be dropped and then your floor joist would sit on top of them. But as you can kind of see in this picture here, we were trying to keep a nice clean ceiling surface. So we pushed those beams up. But in order to do that, you have to use joist hangers to then obviously catch your 2x10 floor joists on there. There's multiple different layers here of this LVL. I believe it's a 2-ply. It's a 2-ply or 3-ply LVL. Up top, you can see the truss roof again. You can see all of our metal connections that are made. These are specifically located and installed per engineering specifications to this particular truss roof, to this particular house. Just another really cool view of truss roofs. I love truss roofs. I think they're so intriguing. A lot of times there are times where you can use truss roofs for most of your project, but then we have to infill our roofs sometimes with stick framing. All right, so just a little difference there. This is a good picture. You can see the two top plates of an interior wall that's catching this truss roof. And this is also the start of our family room, because look, it's flat over here in the front. And then once it catches this interior wall, it goes straight up. So this connection is very particular, obviously, to know where this interior wall is per, where that cathedral is going to be. So they're using the working drawings to be able to create these truss roofs as we go along. Left side, this is a great picture of, the staircase. This is called rough framing. So, which means that this staircase is rough. You're going to be taking off all of the treads, the stringers. These are called stringers, the ones that actually go up and catch all of our treads. A tread is what you step on. Stringers are attached to the treads are attached to the stringers. And then this is an open riser, but by code, we have to actually close this up. So again, this is rough framing. Over here on the right side, these are those wind baffles that I was talking about in our lecture when it came in regards to ice dams. These are the wind baffles that are installed. So you can see that they go up the rafter a little ways, and then it actually steps down towards the exterior wall. This is also your header above a window. You could see, maybe you could see, there's a little bit of space in between this header. It's a little bit different from our book. What we'd like to do is we'd like to be able to get insulation in there, because wood is has a very, very small thermal R value. So it's a thermal break, meaning it doesn't have as much insulation as in between the studs does, right? So this header, we usually keep a space in between and fill it with insulation. Briefly, you can see on the right side of this picture that there is insulation in here. This was in the laundry room. So this is above the washer and dryer. And this wall on the right-hand side is actually the half bath, just to give you a little bit of orientation here. Okay, so this is a fun picture. This is this is a pocket door system. So I love to be able to show my students what this looks like. So those are the doors that go into the wall, right? This is the half bath, right? When you come in the mudroom off the garage, and you can see the plumbing in the wall right now and such. But this pocket door system is actually one of the more expensive pocket door systems out there. There's some that are really crappy. They're made of plastic, they're flimsy, they break, they're just awful. This one is actually from Hafele, Hafele, and it is made of a metal, a gauge that's a little bit thicker. So you have these strong metal studs, and then they put these wood strips on the outside to be able to attach drywall. And then our track system up above is all metal. There's no plastic in this pocket door system. Comparison to what's out there at the local lumber yards, and comparison to this, ordering this, is the lumber yards can get pocket door systems for about $250. This one is about $800. So it really is worth it. Pocket doors are very, the old pocket doors that are in really old, like Victorian style houses or things of that nature, are absolutely beautiful because they used metal track systems and metal rollers, metal wheels on the door system itself, and they never broke. And then we started manufacturing these left and right, and we started making them out of plastic, and it is one of the biggest callbacks for contractors to go back and fix a pocket door system, because the door gets caught within the pocket or doesn't shut right, what have you. It's because something broke and or something wasn't installed properly with these cheaper plastic type of systems. So I like to spend a little bit of extra on these details as to not get a call back, right? I don't want to go back to somebody's house 2 years from now to fix a pocket door with drywall all over it and whatnot. I want to do it right from the beginning. This is just another photo of the header system. We actually put a piece of wood in, we install it onto the track system just as it's the same width as the door would be, and we install it on the track system. Why do we do that? Because we can get our wheels located in the exact position that they will be on the finished door. I've installed many of these pocket door systems, and when I first started installing them, before I did this little trick, I used to have to open up the drywall right back here in order to be able to adjust something in this back end. So now we put a a 2x on there, whatever width the door is going to be, and we install that top part of the track system, that top part that's going to connect to the door, where it will be on the door. So we kind of have a template to go off of as well too, which is great. Okay, this is a corner of some exterior walls here. This is in the family room. We could see that because of the cathedral ceiling up top. Oh, remember the gable wall we were talking about in our book and in our lecture? Oh gosh, I can't remember what the term is, of course, that you should remember, but we have the gable wall that's framed up top here as well too. Anyways, we have our exterior studs, 2x6 exterior studs at 16 inches on center. And then our corners are a little built up, which you do have some good pictures of what that looks like in plan view in your book. You can see that we have our electrical boxes, a rough electrical going on here. With the header system above the window, you can also see that we have jack studs. And we have king studs on these as well too. See the jack stud underneath the header, and then you got your king stud that's holding it all together. You have your sill at the bottom of your window, and then you have your cripples underneath the window. This right picture, I zoomed into these corners because you can see the shiny material that's on the bottom. Here's our sole plate that's attached to the subfloor sheathing. And I go around, I've done this, oh gosh, for about 20 years now for energy efficiency techniques for Energy Star. And when I talk about that blower door test, to be able to find leaks in the house, that means air leakage, so our heating leaving the house through cracks. And some of these cracks happen during the framing process, and the framers do things in a certain way as well too, by putting adhesive underneath these sole plates before they stand these walls up and stuff. But it takes me a couple hours. I go around, I get a box of silicone, and I go around and I do the bottom sill plate on the inside, and I also do corners of exterior walls. And I also do between the jack and the king. Sometimes there's quite a bit of gap here, you wouldn't believe. And I just get that bead of silicone to be able to stop any potential, even just a pin tip, right? Just that small of an air leakage, could ruin one of my blower door tests, but could also just allow heat to escape. And, we don't want that to happen. So just an easy measure. I'll talk about this more in when we talk about insulation, but here we have a couple, let's see how many, two jack studs and a king. We have two jack studs because this door is over 6 feet. And then I did silicone in between these as well too. Over here, you could just see the details. You could see the rough electric details going on. Oh, we can see the corner of the fireplace being built, and there it is. There is the fireplace bumped, framed out into the family room. So now you can kind of see the depth on either side of it. That's going to be underneath these windows. We have our fireplace installed that gets installed during rough frame, because one needs to get electric. We put the electric to it, but also it needs to get inspected that it's vented properly. At the top of this is a fire rating. This is a chimney, right? I don't care if it's gas or not. Actually, this is propane. This house, they didn't have gas on the street, so we're using propane to heat and for the fireplace. But if there was ever a fire in here, God forbid, we have fire blocking at the top plate, so at your double top plate, and then we also have fire blocking where it meets the ceiling. So at every level, you want to do this kind of fire blocking anywhere that could act as a chimney for fire to go up and into. All right, and then this is going down into the basement. You could see this is the back wall where we have that stepped foundation. And then remember, I told you we have a framed area and a window that is big enough for egress. So they can have bedrooms down here and have classified as a bedroom because this is an egress window. So egress is a safety, a certain size, and the sill has to be a certain height off of the ground in order for it to be classified as a proper egress window for a bedroom. Here's a lally column on the left-hand side going up for our carrying beam. My carrying beams are LVL here, so I don't have to have as many lally columns. And then you can see that we built up this point load to carry this beam down to the foundation wall. And there it is. There's the outside of the house with all of the windows in. This is called weather tight. You can see that the roofing shingles are on, the windows are in, a temporary door is in. So this is weather tight. So we can actually start mechanicals without having to put siding or brick or anything on the exterior, because that's what the zip system does for us. It gives us the ability to be able to work on the inside. It is weather resistant. I think it's a, oh gosh, it's a huge gap. It's a huge warranty for this to be exposed to the elements before it's non-useful anymore. So you could, I want to say it's 6 months. I'm sorry, I'm trying to talk and think about the warranty in the back of my head, but we could always look that up. You can see how much dirt is built up on the front here where this picture is, right? I'm standing down where the leach field is going to be, or is now. So this is all getting built up where I'm standing taking this picture here, but you could see how, remember, you know, how high up we had to bring this house. And this dirt, you know, you're probably talking 4 or 5 feet that I'm standing down from the top of that dirt to where I'm standing that we have to fill in. And that's just in the front, never mind, you know, the sides as well, we had to fill in. So this is the small window here facing south that I was talking about on the second floor landing. That's letting beautiful light into that staircase. And then your garage is over here to the left, and the master bedroom's right here on the right, and dining and bedroom up above. And now, of course, we have temporary support for the porch. Just looking around, here's the step foundation. This is rough grade at this point. And you can see how nicely that looks. The venting for the fireplace is going to be coming right out here in this vertical. Framing, we also have to deal with shear walls. So you're going to see every now and then that we have a exterior sheathing. This is 4 feet by 8 feet, is standing upright vertically, and the rest are horizontal. That's to be able to create a corner structure that is strong to withstand wind, right? We are in Massachusetts that has ocean side, and so we need to be able to think about wind and hurricanes and tornadoes and such, even living in Western Mass. This is called, this on this picture, on this right side of this picture, is called a doghouse dormer. So instead of doing a hatchway, if you have a hatchway that you just have those metal doors that you open up and walk down some concrete steps, this is just another way to do it. We framed out this little doghouse dormer, it's called, with some roof. So now he's got an exterior door that he can walk down the stairs, excuse me, into the basement. And there you go, instead of a hatchway. Some people like them, some people, no way, right? Again, just looking at it from a different angle, looking at all the different roof lines. And then this is what it looks like all filled in. So I'm actually standing on the driveway now, but you know, what a difference. So they chose this beautiful blue vinyl siding with some cedar shakes up in the gable end. We used reclaimed wood posts on here that actually came from the land. So I told you that all of the trees that were taken out of here were brought to his buddy's mill company and milled for a lot of different elements for the inside finish. But we definitely grabbed some for the outside finish as well too. The homeowner actually polyed these with a marine grade poly, and just beautiful. We got some soffit lighting in here as well too, which is beautiful. It's even more beautiful now that they've lived there for over a year and a half. Just so much more landscaping has been done, and just a really pretty house. So these are some other pictures just of another project that I did in Springfield that I sometimes do for our construction estimating class. Beautiful, beautiful location right here in Springfield, Mass, with this gorgeous swimming lake. And this was the house that we did some really serious energy efficiency techniques to, and it's quite spectacular. I hope to talk about it through our class as well too. But here's just some pictures. This is a lull that we use for getting those truss roofs up on the roof structure. This is what it looks like through, the rough framing parts of it, getting the first floor in, obviously, and then working our way up, getting the truss roof on. This is a great picture to look at to see that truss roof design. This is 24-inch on center. So remember, I think I talked about this in our lecture that we put sheathing. Sometimes they call for 1/2-inch sheathing or 5/8-inch sheathing. So because it's 24 inches on center, these truss roofs, the 1/2-inch just becomes way too flimsy in between that 24-inch. So it's always nice to go to the 5/8-inch if your budget allows. 1/2-inch is okay, and it's fine to use. It's minimum, right? And code is minimum, and I want to make that very clear. Code is minimum. You always want to do above and beyond code. So these windows right here is all the family rooms. So we're looking at the beautiful view. Orientation was very, very important on this site. We're having, this client has solar panels all on the back side of this roof. So as you can see, there is a little bit of a second floor in here. So this is like that attic truss that we see in our book, a large attic truss, but nevertheless, there is some finished space up here. But on this back side, we needed to make sure we kept it nice and clean so it could allow as many solar panels as we could. So again, it's looking at the view, but this is also south facing sun over here. Yes, we have some trees that could block some of the solar panels, but again, orientation was really, really critical on the angle of this house in relationship to the views, the beautiful pond here in Springfield, and also, getting as much sun as we could. The majority of the solar panels were installed in the upper part of this roof, as to the solar company as well does calculations and figures out, the shading versus the direct sun on solar panels as well. Just a side view, here's a hatchway. Instead of a doghouse dormer, this hatchway is just going to have those metal doors that you open up and just scoot right down in there. And there you go. Here's the door to the garage, and you can see some basement windows. Zip sheathing all the way around with your tape that tapes up the seams. This is a good view of the outside. This is going to be a screened in room. So underneath, we're going to be putting screening under here. Excuse me, this house is already built, so there is screening under here. On top, we actually used reclaimed composite decking on this house. We used a lot of reclaimed materials on this house and did a fantastic job. The client did a fantastic job choosing the materials, and I had some very skilled carpenters working with us to get that recycled material to look brand new. This is the upstairs area. I can't remember if, oh, this is the kitchen. This is the kitchen area. We have I-joist systems up here so we could span these large distances without having any columns in there. So this is actually an I-joist system. And then the pieces of material that you see that are opposite are called furring strips. You never want to attach a drywall to a truss roof. It moves too much. So, excuse me, it doesn't move because it's engineered not to, it's engineered made. So we add these furring strips, and the drywall will get attached to those furring strips, so it has a little bit of movement, a little bit of play. You can see that the zip sheathing, we can actually see the zip sheathing on the inside. This house in particular, the zip sheathing or the exterior sheathing has foam board attached to it. So again, I told you this house was extremely energy efficient. And one of the things was the insulation value that we were able to use for the exterior walls. We have 2x6 exterior walls with a 2-inch foam and then that green part on the outside. So what you're seeing on the inside is actually foam board, but it's attached to the outside green zip sheathing. It comes in one piece. Very expensive, but very worth it in the long run. Because remember I said that wood studs have a thermal break in your thermal envelope. Well, by adding that foam board across the outside of it, you're actually making a continuous thermal barrier on the outside. It might not be as much of a insulation value as it is in between your studs, but nevertheless, it's still a continuous barrier. So your building envelope and your thermal envelope are two different things. Your building envelope is the structure itself, from the foundation all the way up through your exterior walls, your ceiling unit, everything else. Your thermal is the insulated part of your building envelope, the thermal envelope. And that thermal envelope could mean, it doesn't necessarily mean that it's going all the way up to, the top part of your rafters where your ridge beam would be, but that maybe your thermal envelope stops at the ceiling area. And this upper area is not part of the thermal envelope. It's part of the building envelope. Okay, so those two words I want you to know. If they're not on this quiz, they will be on a quiz following. You can see that I have a lally column sticking here into an interior wall. There was a huge amount of point load coming down from the truss roof, from the ceilings and the finished space up in the second floor that actually called for a concrete lally column to be installed in the first floor. This doesn't happen all the time. It's kind of rare. We use wood and other things to be able to carry beams, but the amount of this load coming down in this particular spot even called for certain steel head pieces and sole pieces of this lally column. These had to be specifically engineered to carry the load from the roofs. And then of course there's a beam and a column right smack under this lally column, because this point load needs to be carried down all the way to the ground, all the way to the footing. Okay. Just another view of some corners, and this is going to actually be the HVAC. You can see that there's kind of two walls that are framed near each other here on this one. This is where the HVAC ducts are going to be coming up through and going to the second floor, going to the attic. Just some other details, some strapping that we did for venting. We had to put, plywood up so we could insulate on one side as to not let the insulation get blown over to the other side. You have steel plates everywhere for your truss to get connected to. So just a lot of cool wood details going on here. Just like to be able to show those. And then this as well too, you can see the strapping that we have down bottom, those furring strips I was talking about that the drywall gets attached to. And then we have our truss roof going on. I'm standing up in the second floor, and we can even look out and see the soffit area, right, where that ventilation is going to come up through for the roof area. So just gave you a couple little added pictures there of another project that we had worked on in the past couple years. And I will upload this to our lab folder, and you will have instructions, what I'm going to be having you do. And I'm going to write out the instructions, and I'll even add a second video that's going to explain the details a little bit more of what I'm going to try to achieve with you guys for this week 6 assignment. Basically, what I'm going to have you do, I'm going back to the Granby house that we're working on, is this wall right here. You get a little detail of it, and if you stop this video, you could obviously count the studs that you see in here. But I'm going to have you do this whole right side. If you're standing in the front of the house, looking at the front of the house, the whole right side, there's that little bump out, and then there's this wall, and then there's a front wall. I'm going to have you try to come up with a stud count, so an exterior wood count, and then tell me how many headers there would be. Not necessarily do the gables, but just try to get that first 9-foot wall section, and just to see if you could do a couple of those exercises. I will also add information for your labor, for framing labor, and our costs associated with this lumber package. So again, I will follow up on another video here for our lab that you will have, and you'll have the instructions before our Thursday live class. I will do our live class on Zoom, since Zoom seems to be working better for me in my location instead of Google Meet. So I will add that to our lab folder as well too. So I look forward to seeing you guys on Thursday. Hope you enjoyed this slideshow. Take care.